Hello, friends. Welcome to our podcast channel, The Storytellers. Stories about astronomy, the sky, the cosmos, motivation, music, history, and many things more.
Hello everyone. Today I am going to tell you the story about one of the most finest telescope ever made by the humans, the Hubble Space Telescope. Since the dawn of civilization, the night sky never failed to fascinate our ancestors. They often created a large number of stories regarding those shining dots in the night sky. After the invention of the telescopes, it had become the key instrument for exploring the cosmos, and people started using it to get immersed into the cosmic ocean. The humans started to build observatories with largest of telescopes in different continents that have perched upon mountain tops and away from distracting city lights. The astronomers started to spend long frigid nights inside those enormous dome-shaped observatories, pointing the telescope skyward to get the best possible glimpse of the heavens. But somehow they faced a major obstacle that stood between them and a clear view of the universe, the Earth's atmosphere, which is nothing but a chaotic mixture of gas and dust. It obscured the visible light, causing the stars to twinkle and making it difficult to observe faint stars. So this is the time when the humans realized that if they want to continue their seek for the infinity, they have to eliminate this Earth's atmosphere, and the only way to make this possible is to place a telescope above the Earth's chaotic atmosphere. Here comes the idea of a telescope that could be propelled into Earth orbit by a rocket. In 1969, after Armstrong's giant leap for mankind on the moon, NASA started putting the Large Space Telescope program in jeopardy. The telescope was designed in such a way that it could resolve at least 1/10 of an arc second and have a wavelength range from UV through visible to infrared. Let me explain what is an arc second. We know a complete circular rotation is also considered as a 360-degree rotation. Then 1 degree of that one complete rotation is 1 divided by 360. Hence we can say 1 arc second is 1 divided by 3,600th of a degree. By the year 1985, the telescope was assembled and ready for launch. It was named after one of the most famous astronomer, Edwin Hubble, who was the first to observe the expanding of the universe by using the 100-inch Hooker telescope on Mount Wilson, California. It had been planned that a space shuttle would be used to deploy the Large Space Telescope into space and reel it back for return to Earth. Finally, on April 24, 1990, the space shuttle lifted off from Earth with the Hubble Space Telescope nestled securely in its cargo bay. The following day, Hubble was released into the orbit, ready to peer into the vast unknowns of space, offering a glimpse at distant exotic cosmic shores that are yet to be discovered. After that, when the astronomers were waiting for the science data, they started to face a shocking situation. The astronomers noticed that instead of getting crisp point-like images of stars, they saw stars surrounded by large fuzzy halos of light. They soon realized that this issue was created because the edge of the telescope's primary mirror were ground too flat by just a fraction of the width of a human hair, and as a result, the mirror couldn't focus light to a single point. Although engineers have designed Hubble with many replaceable components, primary mirror was not one of them. Before the launch of Hubble, the engineers had built an improved second-generation camera for the space telescope called the Wide Field and Planetary Camera 2 or WFPC2. The optics experts realized they could build corrective optics into this particular camera to counteract the flaw in the primary mirror. Meanwhile, the Hubble scientists devised a set of nickel and quarter-sized mirrors called the Corrective Optics Space Telescope Axial Replacement or COSTAR to deploy the corrective mirrors to focus their images properly. And finally, the ability for astronauts to upgrade the observatory in orbit ultimately led to a solution for this seemingly unconquerable problem. In December 1993, the first servicing mission was launched to install the planetary camera WFPC-2 and COSTAR, which countered the effects of the primary mirror's flawed shape. Between the year 1993 and 2009, a total of 5 servicing missions have been done for the Hubble Space Telescope. In this period, there was a time when Hubble went to sleep when its fourth of 6 gyroscopes get failed. The gyros measure the spacecraft's rate of motion and help the Hubble to point towards its observation target. Since this was unable to conduct science without 3 working gyros, Hubble temporarily closed its eyes on the universe. Though Hubble was designed to spend at least 15 years in the space, it has exceeded the goal by operating and observing the universe for almost 30 years and has taken more than 1.4 million observations. The scientists and engineers are continuously working to keep Hubble operating for as long as possible. The telescope's observations has contributed to understanding of the growth of galaxies, presence of black holes, birth of stars, atmospheric composition of planets, icy objects in Kuiper belt, the evolution in the asteroid belt, and the nature of dark matter. The explorations have fundamentally changed our perception of the cosmos and will continue to reveal new insights for the upcoming years. One of the most magnificent images clicked by Hubble is the iconic image of Eagle Nebula M16, which is also called the Pillars of Creation. Here, M stands for Messier. The code M16 indicates that the Eagle Nebula is the 16th object of the Messier catalog recorded by Charles Messier. So here we have come to the end of our today's story about the stunning journey of the Hubble Space Telescope. Thank you.